at screens with the weather and the things meteorological, and started talking to him about his work, and realizing that I knew nothing about meteorology. I thought, we have never had in our water seminar history someone talk to us about the meteorological and atmospheric side of water issues. And so one thing led to the other, and I prevailed upon Dan to give us a talk on precipitation and things meteorological at one of our seminars. And so here he is. Dan, thanks for being with us. It's great to have you here and give us your talk on this.
It's great to be here. I look forward to talking to everybody about air quality, weather, and everything that we do related to that here at the office.
I'll hand it off to you whenever you're ready.
Okay. All right. We'll get this underway. Everybody can hear me. All right. Let's put this. Okay. So as the title of the talk was, "What's up with the weather in Minnesota?" It is complicated. As you guys know, Minnesota is kind of like the Super Bowl of weather, as Paul Douglas used to always say. And the past 2 weeks alone have proven that for all of us that we've experienced, either not at the office, but out in the field or at our homes here in Minnesota. And so I wanted to just give a go through of what we look at each day as the AQI meteorologist group, looking at weather, which we do every day. We pretty much know what's going on with the weather 24 hours a day, 7 days a week, because we're meteorologists and most of us are what we call weather geeks. That is a complimentary term. So don't feel bad if you call me a weather geek, because I would smile at that, because that's what we are. Um, so I wanted to just go through a daily process and then also highlight some different things that we're doing and things that we look at, how they all tie in together. It might surprise you of how interrelated weather and air quality and disasters in the weather field are to our jobs. So good to good to do that. And for those who did attend the severe weather seminar back in May, that Matt Tarleton and I did. I appreciate you coming to that. And we'll probably do that again if there's enough demand, maybe in the fall, but we do it every spring. So we like to keep people up to date. It's always a refresher to follow severe weather. So who are we? We are the air quality meteorology staff working in the EAO division. We work under the air assessment, and we're in the risk evaluation air modeling team, or the REAM team. And so we do that component of all things atmospheric. So we do dispersion modeling, which is our primary role. We do air quality forecasting and alerting. We also opened up to do weather ready ambassador messaging for, and that's part of the NOAA National Weather Service program. So anything that's impactful weather for the agency statewide. Operations relies on our information. Emergency management uses it. So we have a good relationship
Daniel,
helping those groups
we cannot see your
across the
screen.
state. You
Okay.
can't see the screen?
Hi, Dan. I was just sending you a message in the chat that it's just gray. I was waiting for something to start, but I can see like your Apple icon and Keynote but the actual screen itself is gray.
Okay, sorry about that. Let's try something different. It's always technology that gets you.
Yes, you trying to use an Apple device with the rest of us are on.
I do have a backup plan in case this didn't work. It's just that it works so much better with my microphone and so forth.
Yeah.
So when I show this, do you see this screen here, or is it just green?
No, it's just gray. I see like the top, the header with the file edit, but it's gray otherwise.
Okay. I'm working on a backup plan. Everybody just, you know what? While this is loading up, play a little music, the backup plan.
Well, I think, Mark, you have some jokes lined up as a backup plan, don't you?
Oh, yes, I'm sure I do. Yeah. If I can just recall any.
Let's see. Let me change things around. I gotta switch my microphone headphones from the AirPods to something else.
Yeah, that's actually a good point. I did notice that you were logged in twice. Well, maybe now you're not. But at one point you had two, there was two Daniel Dixes on the list here.
He's still loaded twice.
There we go. There's something.
Oh, yeah, you are still on there
the
twice.
screen
Yep.
here?
Yep, we can see that. Perfect.
You can see in here.
There we go. Now it's up.
Still a lot of gray in there, but there's buildings and roads.
Yeah, but you can make that full screen, I think, right?
Okay. You can hear now?
Nope, now we just
About
see
now?
you.
Back.
Now we see you. Lost the screen though. And I do see you twice. We got two video cameras of you.
Are we back? Are we back?
You're there.
Okay.
I don't see your presentation though. I just see you.
Okay.
Good.
Good.
That's,
So that's
step one.
one.
All right. How about now?
Yep.
Okay.
Okay.
The microphone,
May not be as high quality, but we'll go with it. Now everybody can see the screen?
Yes.
Okay, cool. So we'll go to the introduction super fast. And so I already talked about what we do, who we are, and we work with a lot of things atmospheric, dispersion modeling, forecasting, the ambassador messaging, and we also deal with the man-made pollution disasters. So our main thing that we do is air dispersion modeling. And many of you have seen the work that we've done this working with permitting, environmental review, and other portions of the agency to support anything related to air quality using dispersion modeling. In that requires a lot of input data, and one of those big inputs is meteorological data. And so we run the models with processed data from the state of Minnesota that we do. So it requires a lot of meteorological review of that information, as well as working with permitting for all the emissions, all the building information, so forth, to help support dispersion modeling for any projects. So another thing we do is, as you know, is air quality forecasts and the alerts. So these are actual notes that we take on our iPad on the image on the right. We do the alert map. We look at all sorts of information. We look at the data on the left is smoke and fire, high split information, wind trajectories, pretty much the whole 9 yards. And the air quality forecast program began in 2017 when we took it over from a contractor. Yes.
Could you, I muted your other, because you're logged in here twice, and so we're hearing you kind of a little bit of an echo from your other computer. Is it possible to turn that one off? Mute at least the, okay, now I have to unmute this one. Okay, now try.
1, 2, 3.
Yep, perfect.
Okay, cool. I know. I overcomplicate things sometimes. My bad. So
No, you're good.
I wanted to be really. I had to actually take away some of the animations because I knew it would be an issue. But one day when we're back in the office, we can really show you some cool stuff. But we'll get through this one. So the technology changes, the agency operations. We basically have the meteorologists more involved from beginning to end. was the goal of us taking over this forecasting alerting program 2017. And also we did a deep dive into social science engineering, improving the messaging, the understanding. So we work with Department of Health, we work with our communications group at MPCA, as well as Department of Health, and also MnDOT. And then a lot of our outreach efforts were really ramped up since we took over the forecasting program in 2017. And we like to call it our One Minnesota AQI. And we thought of that before the governor. We thought we were clever, but that's okay. Monitor locations, as you know, and throughout the state, we have monitors across, and this is from the Air Monitoring Review Plan. Pretty decent coverage, Twin Cities, maybe Duluth, Rochester, the major cities, and a few locations in the north. And so the original forecasts were just Twin Cities and Rochester, and that was it. And so when we took over, we expanded that to over 18 locations statewide based on those monitor locations, split the Twin Cities into 3 because of the differences that we found in the metro area. 5 tribal locations, so we work with the tribes and have a good working relationship with them. And then again, we based on monitor locations around the state. So pretty decent coverage. There's a few gaps, obviously, in the far north and the west and the southwest, but we feel we have a pretty good idea, and that helps us to do statewide any type of alerts that would be expanse beyond these points. We developed an in-house artificial intelligence model, which was important. It was basically from off-the-shelf software using Python, ArcGIS, and we use Tableau, all integrated into our model creation. And it really allows machine learning on the fly in-house. And so there was a data set that was built to train that model using past meteorological measurements and air quality measurements to learn during these situations what happens when the air quality is this, what are the meteorological conditions. And so that was built up to start the model, and that will be continued. We're going to be retraining the model with newer years of data for meteorological and air quality. So that'll be making that model even better. We use meteorological data every day that will run into this model, upper air soundings, a lot of different information that goes into this. So now when we run that model on a daily basis, we pull in all that information, the live data now, thinking of what's happening in the past, it'll replicate it with real data in today's world for background monitoring, the meteorological, and we also will then look at the meteorological model for the NAM, the North American Mesoscale, and the Global Forecast System, GFS. That's what all meteorologists look at, released by NOAA. And we look at the current weather, we analyze it on the iPad, draw out the map to get a really good feel. Computer generation of weather conditions currently only goes so far, and we have to forecast air quality and the very small minutia of details that you need. Doing hand analysis still is the best way to go. We process the weather data, like I said, the background information, the inputs in the background, they all are pulled into the model, and we run it, and it creates an output. It's forecast or it's guidance. And from that, we look at it and say, well, this makes sense, doesn't make sense. We'll adjust the numbers based on these conditions. So that's where the meteorology, the human, has to stand in because models aren't always right, as we know. And the output goes into, we use Tableau, and we see our locations on the left from Lake Brainerd down to Lakeville locations. And then we go by day 0, which is today, day 1, day 2, day 3. And you can see all the different model runs and their values of whether it's a green or yellow or orange based on the AQI scale. And so that gives us a pretty good feel of what the different model runs are showing. And then it helps us to, the strength of the forecast. Is it doing well? Is it handling well? Is it not? Because sometimes you will have an outlier. And then our output will go to the different versions of the platforms, from the web page to EnviroFlash emails to Twitter to airnow.gov, which is the EPA's air quality website, and of course the Minnesota Air app, which I'm pretty sure everybody on this call has that on their Android or iPhone or their tablet, right? I hope so. If not, by the end of the day, you can have that downloaded for free, and it's a great app to have on your device to use. So what are we forecasting? People will sometimes ask, well, you do all this work, what exactly are you forecasting? And so what we do is we look at the EPA's Air Quality Index scale, and we forecast of the criteria pollutants that are modeled or that are modeled on like in dispersion modeling and things like that. We look at ground level ozone and particulate matter 2.5. Those are the two have found to be the most impactful on health of the 5 or 6 criteria pollutants. So those are the ones that we do focus on, as do all other agencies across the United States. So like I said, we forecast ground level ozone and particulate matter. And the particulate matter comes in a lot of different forms. We get it from wildfire, we get it from prescribed fire, winter stagnation, recreational, wintertime burning, agricultural impacts, harvest, fall fertilizing, dust storms, and even special industrial accidents. And you'll notice anything that has smoke in it will also impact ozone because of the complex chemical reactions that take place from all the VOCs that are in smoke react to sunlight, so we can actually have high ozone and have high particulate matter. So that always makes things interesting and challenging for forecasting and alerting. These are the categories many of you have seen or known, but it's a good review. This is the air quality index categories. You can either go by color, green, yellow, orange, red, to magenta, or you can go by good, moderate, unhealthy for sensitive group, or USG, or unhealthy, or you can go by the number. So there's multiple ways you can look at that. So it applies to however people's thought processes works. But the colors and the one word signifier for it seems to work for most people, and that's great because whatever works for people is what we want people to use and for their decisions. We actually have a little magnet that we made. It simplifies it more. You can put it on your refrigerator, carry it around, whatever you want to do, and it's really quick guide to the AQI.
Hey, Dan.
So, yeah.
Can you take a moment and just explain what winter stagnation is, please?
Winter stagnation, that's a lot of times in the wintertime, we'll have where you have an inversion that forms warmer air above the surface, so the pollutants will get trapped. And a lot of times that happens if we have a cloudy day. It might warm up a little bit, but still cool at the surface. So the pollution that happens from cars and industry like that, it gets trapped. It doesn't allow it to rise and disperse. So you have a couple of cloudy days and you have that warm air on top of it. It traps that. And so that is common. Usually when we get some snow and then it warms up a little bit, and then we have that melting and all the warm air just park right on top of us from a high pressure. It's like a multi-day event usually. We don't get them as often as we used to. We had one last year in 2018, but they're not as much of a deal as they used to be, but they're still an issue that we look at for PM. Yeah, thanks for moderating because I can't see the questions or anything on the side. So when the air quality gets bad, we issue an air quality alert. And that's usually if it's measured, but a lot of times it's forecast. We try to be proactive and not wait until a monitor goes up because by then it's too late. People can't take action and do what they need to do to improve, take safety, go inside, whatever it might be. So we try to forecast this in advance as much as possible. Ozone or PM because of smoke and things like that. Based on our forecasting, our experience, and the data available, we're able to do a pretty decent job of getting ahead of that. And that helps inform people, anywhere from 8, 12, 24 hours or more in advance. And that's helpful. So we added the map a few years ago using GIS. So that's really important usage of our technologies with the various layers that are within that. And then we export that map like a PNG or JPEG image. And that's used for social media on our website, emails and things like that. But there's another component of that map, and I'll explain that in a moment. So these are the different platforms that you'll see that map on our website, or you'll see it on our Twitter, or news stations will use it. They'll put it in their stories. And you'll also see it in the lower right corner of the National Weather Service website. And that's actually generated not from that image, but from the underlying data, which I'll explain in the next slide. So there's different ways that information goes out to everybody. So we'll draw that map, and then we'll export that image. But underneath that image are the data layers in the GIS from the shapefile. We run a script in-house that creates a National Weather Service formatted product. And that way it allows it to go to the National Weather Service, which we FTP, it gets there in seconds, and it populates their map. And then they send that out as an air quality alert to the public. and that will go to TV stations and things like in other entities where automatically, in this situation to Channel 4, for example, it automatically populates their weather graphics workstation. They don't have to draw that in. And that's just like a winter storm watch or flash flood watch, things like that. It's the same exact technology. So we do all the work for the Weather Service. And I think we're one of the very few agencies that do that, that create that product for them. So some places will email and say, hey, we need it for these counties at this time, and they got to draw it up and type it in. We do all that for them. So because we understand that takes time, especially if the weather's busy with other things going on. These are the other platforms. Upper left corner is the Minnesota Air app. As I mentioned before, you will get an air quality alert notification through your app. News release, Gov delivery, the MnDOT signage, you see on the lower bottom. So that's part of our collaboration and work with MnDOT, improving that messaging. And then also if they come and interview, we do the phone. So we try to cover as many different means of communication to the public and also internally for people to get the message. And that's been a big change from the past where we really have expanded that. We do check and verify forecasts every day. So it's not like we make up a forecast and nobody knows what's going on and we hide the data. No, it's there every day. We see if we did well or if we didn't do well. And then we look at what went wrong, what did we miss, and then we can correct that and learn from that. And that's pretty standard work in the meteorology field, is always refining, always learning, always updating. This is an example here in the PM25 on the right side, our forecast versus the monitored. It was a busy day. We had a lot of oranges, and that was during a wildfire smoke event. Yet we did really well for that, all things considering. And so this is another way that we look at our data. You can see the output for each of the sites, the monitored value, our MPCA forecast value, and then each of the different model outputs. Sometimes they're pretty crazy, sometimes they're different, very similar. And so we have to know what to go with based on our experience. Sometimes it's gut feel a little bit and what you've seen before, and that goes a long ways in meteorology. Now this is a movie file. Hopefully it will play okay. This is a nice depiction of what happens during a big wildfire event. This happened in 2017, right there in the state fair when we were working. So this shows the fires out in Montana and also in Canada. And you have a frontal system that's set up and the smoke, and there's a jet stream, and you actually had a hurricane remnant of Harvey just to make things even more complicated as a blocking pattern. But you can see as time goes on, the smoke makes the move to the east and to the south. The front pours down into Iowa, and then that smoke comes right behind it, which is pretty typical. And so in Iowa, they actually had some pretty bad air quality. And then the frontal system moves into the northern plains, the winds switch around. And guess what? The smoke decided to track back into Minnesota. And so seeing that taking place early that morning with the wind shift, we issued an air quality alert in that area before the smoke got into that area of Minnesota. So there's just times where you can't get it too many hours in advance because smoke is a tough one. It moves in different directions and you never know. But that was really looking at all the meteorological parameters of how the smoke is moving. Is it lifting? Is it dropping towards the surface? Is it moving horizontally, which we call advection? All those components, and then you got to put that in your head and almost like 4D thinking. 2018 is a busy year. We had our first statewide air quality alert. There's a big area of smoke that moved in across northern Minnesota and encompassed the entire state into Wisconsin. Eventually that went all the way to the Great Lakes and parts of the East Coast. That was a big event. For the entire state to be orange, that was a new one for us. And it was a record year in 2018. We had a lot of wildfire events. This is a history from all of our air quality alerts in 2010 up through 2018. In 2018, we had 10. So that was the all-time high. And most of those were due to wildfire smoke or related. Only one was due to winter stagnation, and that was late in the year. So the climb, as we had noticed from 15, 16, 17, 18, was definitely on the rise, and that correlated quite well with the wildfire season. And this is a map of all the counties and how many times they actually had air quality alerts issued. And you can see the Twin Cities was not the worst. It was up in the Northwest because of all the fires that would come in. from the northwest, or sometimes they would come from the north. In Ontario, occasionally we had smoke that would roll in from the south because of prescribed fires in Kansas during that year. So it's definitely not a Twin Cities thing. It's not a big city. It is a statewide issue, and that's going to continue to be the case in the future. Now, 2019 was very different. We had wildfire smoke, but we got lucky because the fires in Canada essentially shut off in July. So you can see the number of alerts officially we had was 2, big drop from 10. But that doesn't mean there wasn't smoke in the air and there wasn't a situation. It just, the atmospheric conditions were set that it didn't always reach to the surface. Because there's times you see smoke on satellite, you see these smoke maps, and seeing on media, it's like, oh my goodness, the air quality is terrible. It's like they're not looking at the meteorological conditions for it to actually reach the surface, which is what we do. And so when that condition is there, then we would issue the alert. If not, we don't. It's just as important sometimes when not to issue an alert as to when to issue an alert. Same thing in weather. You don't want to overwarn or over alert because the public starts to become numb to it and they don't listen anymore. The map on the right shows the Canadian wildfire. Usually there's red everywhere, and that's what 2018 looked like. Where 2019, that red area was much smaller because they had rain and thunderstorms, not too much severe thunderstorms with a lot of lightning, so to speak. They had more general rain shower activity, so they didn't have lightning cause fires as well. That can't be said the same for western parts of the United States. There was California had a very high fire risk, and you remember on the news they had some terrible fires throughout California in 18 and 19. And based on these outlook maps I see for this year, it's not looking good out west, and also in Canada. It's very dry. They've had a lot of heat. We were expecting a pretty busy wildfire season. But the events that we did have for 2019, we did have one in late May, some smoke that did come in. But notice the AQI values that day for PM stayed in the yellow category. They never got to orange. It didn't work down to the surface. There was not a thick enough layer at that time. So we got lucky on that one, despite what it may have looked ominous on satellite or some of the model runs. It just wasn't working down to the surface. However, it did help do another pretty interesting thing, is that the ozone values went up. And so we had some fairly high ozone values in Detroit Lakes, Brainerd, Mille Lacs, as a result of the smoke and the VOCs remaining in that. And we had enough hazy sunshine, and the temperatures were in the 80s, near 90, that it actually cooked the air a little bit, and the ozone went up, whereas the PM was the secondary factor. So that was interesting and a good learning point for us to take into account. The next day, that area of smoke then traveled southward to central and southern Minnesota, and we saw it potentially was going to be a little bit higher ozone than up to the north. And so we did issue an air quality alert, but it wasn't for PM, but it was for ozone, even though there was smoke in the air. So did we tweet that out? We'd like to use that, of course. And we did an explainer, not only in the air quality alert, but in Twitter, is that the wildfire smoke with its gases coming to the VOCs helped to create the ozone because of the production, the chemical reaction with the sunshine and all those VOCs. And we did have some pretty high ozone numbers in the Twin Cities and at Marshall. So that was an interesting and very different type of alert than probably has ever been done in the past, because of our experience and learning more and more about air quality. And then the second and final air quality alert of the year, this was a big one. This was the set of fires that came down from Canada and into northern Minnesota, pretty much the northern third of the state, heavily impacted by the smoke. So the fires that were in Kenora, north of Kenora in Western Ontario, they went up very quickly on a Friday afternoon, Friday night. So of course, this all has to work into Minnesota overnight, Friday night into Saturday morning. And our weather partners at the National Weather Service in Duluth actually messaged me saying, hey, you guys, we're seeing some pretty heavy smoke coming in, these fires that went up late Friday night, and the wind shifted. And I was like, okay, took a look at it, like, wow, it was really coming in strong and heavy and thick, and the right meteorological conditions were there, where we saw the air quality conditions were starting to deteriorate quickly at some of the monitors up north. And so we had an air quality alert put out, and it was put out Saturday morning, sitting at the at my desk here at home, and because of our capabilities with our AQI laptop, then that extended through Sunday afternoon because we didn't see it breaking up right away, and it did. It hung in there until probably late Sunday afternoon, even into Monday. The air quality improved somewhat, but as far as hanging in the air and people noticing it, it was a pretty bad event. And we actually had some purples for 1 hour values at the Red Lake monitor. So it was some pretty nasty air, even though it was just the one event. In fact, it was the highest measured AQI values in the state of Minnesota since the monitors were installed in the 90s. And at Red Lake, they had an AQI at 1 hour of 272, which is pretty impressive. It's probably the one time I've ever seen purple, even for 1 hour or a set of hours in Minnesota. So the things that we've learned for our air quality forecasting, we have to expand our air monitoring network, more cameras, more weather stations, more remote sensing data, and learning more and more about wildfire from different websites and coordination with the Canadians and also in the state of Minnesota. So here's our current network of our monitors that we have, and for MPCA and also at the tribe locations, which is pretty good. But if you notice along the border, there's nothing there. We're kind of blind. And so the thought was, looking more as I saw these purple air sensors, there's some others out there, but purple air has become very popular, and they've been tested by the EPA as pretty reliable. They're not bad. In fact, the EPA is now going to incorporate the purple airs into their smoke fire product on the air now. So there is enough credibility to these sensors that they can be used. So we plan to install, we have 25 to put out into a network, so to speak, along the northern border. And these are all the sites subject to change. We're adjusting, and we'd like to have them all installed and really cover the state better for any wildfire smoke events, and in the south for prescribed fire that comes from Kansas and Missouri and Iowa. Just to have more eyes, more things to detect. The smoke is what helps us. In the Twin Cities, we also plan to expand and have some. There is one in Burnsville now. As I look out my window, it's about 20 feet away. It's sitting there, so we can track air quality. There's one in Hastings at David Brown, one of our meteorologists, that's at his place. And then Dorian Cavalli has one in Minneapolis. And there's a couple in Monica has one out in the western part of the metro. So we're expanding the network in the Twin Cities as well. We use haze cams. We have our Bloom Sky. These are the views from St. Paul and the Duluth office. And then Leech Lake has one, the tribal location up there. So we look at that one as well. So that's pretty neat. And I mentioned earlier remote sensing. We're now becoming an early adapter partner with the federal other state agencies with NASA, the Marshall Space Flight Center. So they're creating what's called the Tropospheric Emissions Monitoring and Pollution, or TEMPO. It's a different TEMPO. But this is one that's going to be part of a satellite that's going to be launched in 2022. And its resolution and timeliness and ability to detect air pollution is incredible compared to the existing satellites that are out there. So that's pretty exciting to be able to be a part of that team. And we'll have more information as we learn more working with them, the data and the type of products that we'll be able to have in-house to use with forecasting and monitoring. And I think some of the information will be able to be used by other groups as well, which is pretty cool. Also with the Weather Service, Duluth and Twin Cities, they do satellite webinars, and they've invited us to that, how they use satellite for weather, and also for we could apply it to air quality as well. So it's pretty neat stuff going on there. Finally, for man-made pollution disasters, the Husky Refinery fire in the Twin Ports area of Duluth Superior back in April of 2018. That was an interesting event. We got lucky because the winds were out of the northwest, and we took a quick look at that, ran some high split runs, provided the information to the Emergency Management Union. That was kind of interesting because they didn't know we did that stuff, and so we said, "Yeah, well, I think we can help out." And so we provided help on that. We coordinated with the Weather Service office in Duluth and did a lot of phone calls and discussions that day. So it was a pretty quick, fast spin up of how we can cover these types of situations. And with that tracking, you show that smoke going farther south, and never really got into the city very much until the very end. By then, and as a lake wind switched around, a lot of it had been dispersed, thank goodness. There was some other type of pollutants that were in the air, but at least as far as PM, that was not an issue, thankfully. The other big one was the northern metals. So we provided assistance with that in our forecasts and also some graphics, some data, because that smoke and all the pollution from that did come down into the Twin Cities. In fact, it reached all the way to Chicago. So we were keeping up with that on Twitter and our forecasts, and also need help internally with emergency management. We provided some information as well. And then finally, the Weather Ready Ambassador messaging. And this is a program developed by the National Weather Service across the country. It's basically, if you're an ambassador and you can earn that with the Weather Service, you're helping your agency, your company, your nonprofit, whatever it might be, just making everybody aware of what the weather hazards are out there, if there are, and then what are the best actions to take for safety. And so we adapted that, and we thought this would be helpful. We have offices around the state. We have all types of weather that impacts operations, not only in the offices, but out in the field with water and air and solid waste. So it was really important to maybe tailor that information better to our uses and our needs. And that's what we try to do. We don't get too technical, high level. I don't throw in. I think I did once, and people started asking, what in the world is that? And it's like, all right, we gotta tone that down, and we want to make it as plain language and as user friendly as possible for all groups. We were involved with the Duluth office when they had the lakeshore flooding from winds a couple of Octobers ago, and they actually had to close the office because we said this is going to flood the parking lot and cause problems, and it did. And so that was an example of how we were working internally with our operations and emergency management unit on that. So, and air quality alerts, believe it or not, is one of those hazards. It's part of Weather Ready Ambassadors. So we were already doing that. It's just another way to encompass what we're doing into a role that helps satisfy the agency's needs across the state at all the offices. So finally, a look at a weather event. You can't have a weather presentation without a nice, fun case study. And this one is cool because not only did it have all the factors you could possibly think of, except for the kitchen sink, is pretty recent. So you're going to remember this fairly well and go, oh yeah, that makes sense. Ah, got it. So this was from last Tuesday, June 2nd. And we had quite the weather event from about the Twin Cities, especially southern Minnesota. So we had damaging winds, we had hail, we had reported tornado. I think it might have been a gustnado, but it still happened. We had heavy rain, some localized flooding, and we had ozone. So we had everything, and that made for quite an interesting week. So Nick Woodcraft was the forecaster, but obviously David and I were looking at it, and we bugged Matt too on the weather side of, we're all kind of looking, wow, this could be a significant event. We better keep up on it. So the day before, we sent out the weather ready message to everybody, say, hey, heads up, this could be impactful, especially the southern half of the state. This is what's going on. And then the next day, Tuesday, June 2nd, based on the Storm Prediction Center, which is the SPC, part of the National Weather Service, they do all the weather watches, severe thunderstorm and tornado watches, and they're based out of Norman, Oklahoma. They issued an enhanced threat for severe weather across southern Minnesota. That doesn't happen too often here in Minnesota, so that's a big deal. So we did additional messaging with that. We used their graphic that the Weather Service have, and the timing of that. We don't draw a lot of the graphics, we don't have time. So we use what they have based on our knowledge of the weather and put it out there just to value add and to help folks make decisions. Even though we're not all at the offices, it's still important to be aware of it for your personal safety, family, if you're going to the cabin, whatever it might be. But we also had to be concerned with the weather with our forecasts. So on Monday, the next day forecast, we had higher ozone for the South Metro and for Rochester. And so it's kind of interesting when you look at the discussion here, and Nick wrote this. This is a really nice job how he's explaining For on Tuesday, it was going to be an upper level disturbance that's going to move in. We're going to have showers and thunderstorms. That boundary is going to help enhance the ozone formation across the southern Twin Cities down into Rochester, but we don't expect it to get into the orange category because of the timing and the intensity of the thunderstorm. So knowing the weather is critical for knowing the air quality, and those two work together quite nicely, and that's where doing a lot of the work. For example, the surface map that morning is actually at 7 a.m., not 10 a.m. So that's what it looks like, that station plot, all the hourly measurements at the airports, your temperature, your dew point, your wind direction, cloud cover, pressure, all those go into these station plots, and that's what it looks like. Piece of cake, right? So we do the analysis of that map, and that's where you will find your fronts, your temperature areas. So we analyze for temperature, which are isotherms. We analyze dew point, which are isodrosotherms. Pressure is the millibars. And then that really gets a good feel of exactly what's going on. And then we also look at the air quality measures in those areas to know, okay, this is what's happening in time. Is it going to rise? Is there more pollution moving into the area? Is it going to increase? We look at 850 millibar, which is about 5,000 feet. And this is from the weather balloon soundings that are done twice a day. So here's what the analysis looks like when we're done with it. And so we're analyzing temperature. We're analyzing the height lines, the black lines. Is it a trough? Is it a ridge? Moisture, which is the green. The wind direction, is it cold air moving in, warm air moving in? This is at about 4,000, 5,000, 6,000 feet in the atmosphere. Extremely important to know what's going on at that level of the atmosphere. And then we also look at 500 millibar, which is about 15 to 20,000 feet in altitude. And here we analyze similar things, the heights, the black lines. Is there a ridge or a trough moving in? What are the temperatures? And also, if you see the dashed brown line in Montana, that's what we would call a trough, or a short wave, or a vortex, or in plain language, an upper level disturbance. So those are the terminologies that we use in meteorology. And you have to visualize the surface, the 850, 500 millibar levels, and that's what you see is going on in the atmosphere at that time. And then we'll look at models and stuff like that. We don't look at models first. We look at the actual data, which is important, both for meteorology and for air quality. Moisture transport on the left is a product that we look at for severe weather and also for rainfall potential. On the right is surface-based energy. That is my layman's term for CAPE, which is convectively available potential energy in joules per kilogram. That makes sense? But that's what we look at, and that changes every hour based on information. We look at shear, low level 0 to 6 kilometer, from the surface up to 6 kilometers. The difference in the wind direction and speed, critical for severe weather development and storm. We look at the winds, the crossover in the product on the right, the 850-500. Low level, mid level winds, how are they changing? What's the strength? Because the stronger, the more shear they have, the more difference in direction and in height and in speed, the stronger, the better atmosphere you have for storms to develop. Monitoring, forecasting, AQ, the air quality. Well, we got to go back to that. So by 2 or 3 in the afternoon, we're looking at the current conditions, and you see Stanton, which is the 65 south of Lakeville. So they're at 65 parts per billion. So they're high into the yellow category. Rochester has shot up to 77, which actually just nudges into the orange category for that 1 hour. So we knew that was going to happen, and that was well forecasted. So nice job, Nick. We did have a quick, between David, Nick, and I, we had a quick Teams call, discussed it, went over it. We put out like a tweet, and we drew a graph. We just explained to the public what was going on, but we felt with the thunderstorms coming, this was going to squash that and ended it, and it did. So it was pretty cool how everything just came together. The Storm Prediction Center forecast for severe storms on the left, where they thought there was going to be severe weather. If there wasn't their watch already issued, they would probably issue one. On the right is from the Weather Prediction Center, a lot of acronyms in the government at the federal level as well. They're in DC, part of the Weather Service. They look at the heavy rain and the flash flood potential. The local offices will issue the actual warnings because there's so many that these national offices can't do that, but the locals will look at this as guidance, as well as TV stations and everybody else looking at weather. So the local offices, Twin Cities or La Crosse, Duluth, whatever, they'll issue the severe thunderstorm warning, tornado warnings, flash flood warnings, because they're so localized and small, and so many of them, that's their job. So here's a fancy look at radar on the left. This is the tornado warning that was near Mankato in Blue Earth County. So I grew up in Mankato, so I was very familiar with exactly where this was happening. Good thunder, moving to the east. The red polygon is the tornado warning, and the yellow polygon is the severe thunderstorm warning. And you can see there's 4 different products. You won't see these on TV, but different ways that meteorologists will look at that radar data to determine what is going on. And then on the right, we have those storms moving to the east of Mankato, headed towards southern Minnesota, now coming into Austin and Rochester. So we're tracking that, knowing it's along that frontal boundary that enhanced the ozone. So here's a radar loop. Hopefully people can see this based on connection speed, but this is the storms. These are the storms that are moving into Austin, into La Crosse, moving from west to east, producing some pretty heavy rainfall. So here's a satellite loop. Hopefully this works. This is visible, so you can actually see with the naked eye what the satellite from 23,000 miles in space is looking at, and you can see those thunderstorms blossoming up rapidly over time. You can see other things in there over South Dakota, North Dakota. You can see high cirrus. See if we can re-loop this again. You actually can see cirrus plume, high clouds over that. So that's the jet stream that we're seeing, and that's all moving into this. You can see the convection, the thunderstorms here. I'm going to pause it. If you look right here, you have these overshooting tops. These are shooting into the stratosphere. These are some pretty strong storms, and that's what's producing that tornado warning in the Blue Earth County area. So, and they have some large hail with that. So that's a pretty good satellite signature of severe weather. This is infrared, where it measures the cloud top temperatures. So you can see things blowing up like 2 giant fried eggs, and that's a pretty good idea that there's some severe storms going on, heavy rain, hail, damaging winds, and potential for tornadoes. Just want to show you something super quick. So you have these really cold temperatures, and you get these deeper colors, and then in the middle of the storms, this is actually warming here, and there's some of these little warming. That's where those overshooting tops were. So they actually got up to the stratosphere, and then the air around it started to sink, and you had warming. So that's what was called an enhanced V on satellite. So it's a pretty weather geeky, nerdy thing to look at, but it really tells a lot about the intensity of the storms when you're looking at it. And finally, this is water vapor. You may not see this too often on your television station, but this is a measure of moisture that's in the air. So they have a different color table. And obviously the greens and the blues there's a lot of moisture because of the thunderstorms, but anywhere you see that orange and even red area, that's very dry air. And that is a pretty good idea of the air masses that are in place. So you look in North Dakota, very dry, cool air that's moving in behind this whole frontal system. And it really dried things out after the system came into place. But when that dry air is over Minnesota on a normal day and we have sunshine, that is actually a pretty good indicator that we're going to have some pretty good ozone. So we keep track of satellite, not just for severe weather. These are the precip totals for the storm, and you can look into the Gulf of Mexico. That was Cristobal being picked up by radar and satellite detection for precipitation. And then you head up to southeastern Minnesota, northern Iowa, and western Wisconsin. So this is important to know for forecasting precipitation and also afterwards. So there's many different ways to measure it. Radar estimates, all the different local radars on the left, a composite of the totals. Anywhere you see the oranges, you're getting into the 1, 2, maybe 3 inch rainfall. And on the right, if anybody has heard of Kokoraz, these are all the observations, and you can see the rainfall totals in southern Minnesota, down by Malheur County, the Austin area, in that 1 to 2, maybe 3 inch range. So there's definitely an increase being detected by the ground as well as radar. So they line up pretty well, and those are very useful tools. These are the severe storm reports, and so H is for hail, and W is for wind reports, and then we have the T's for tornadoes. And these are severe storm reports that come into the National Weather Service So it was a fairly busy day across southern Minnesota. Pretty quiet in the Twin Cities, thankfully. The final AQI numbers, believe it or not, were pretty good for the ozone. They fell into our range of forecasting. We had a 90% score for our forecast. So again, nice job, Nick, on that. You had a busy week, let's just say. For the forecast, we were in the yellow category. Rochester, made a run for the orange, but it held off because of the timing of the thunderstorms. So that was a good job on that. So what's the future hold? Climate change is something that we have to take into account for our forecasting of the future, and we're well aware of what we are in store. And then beyond Minnesota, wildfire threats, the regional transport of ozone, dramatic storms. We saw that in the last 2 weeks alone. Increased frequency of these, the wildfire smoke pollutants, the warm season ozone, wintertime stagnation. Those are things this potential, especially the wildfire smoke and the ozone. Those are the big ones that we were concerned about. So we'll keep doing research on air quality forecasting, improving AI modeling, more data, more obs, more remote sensing, training, working with other partners, more experience with their meteorological team, outreach and education. This is a great example. We want you guys to know what we're doing and what we are trying to do for the future to improve the product that the agency puts out. And just to throw this in here, to work remotely, that's a new thing that we all have to keep in account. So who knows how long we'll be doing this for. So you got to deck out the home office. So this is actually what I have at home. And so no matter what I'm doing, if I'm looking at a spreadsheet or Tableau or Tempo or something, I always have at least one or two other monitors where I'm looking at the weather to know what's going on. So that's not terribly unusual for some meteorologists. We get into the weather a lot, and then for me it's weather and air quality, and the same thing for David and Nick. Just what we do. So finally, I wanted to say thank you and I give a shout out to all the MPCA meteorologists. We actually have 7 that are on staff. Our team of 3: David, Nick, and myself, and then Matt Terrelson, who works for GIS, but also an excellent meteorologist. He's helped out a lot, and he's working with us for our improvements in AQI. And then also in the other offices, Clint is up, I think it's Detroit, Lakes, or Brainerd, I can't remember. And then Elizabeth, she's in permitting, and then Anastasia, she's in St. Paul office as well, working remediation. So there are actually 7 of us who are weather geeks in some way or not. And with that, I will end the talk, and if there's any questions or thoughts, feel free.
Yeah, so we do have one question already started here.
Okay.
So if folks want to put their questions in the chat, and then I'll either call on you or I can read your question for you. So we've got one question already. Have we received any feedback from the tribal nations or environmental justice areas on our improved air quality forecasting and how it has impacted their lives or communities?
What we have learned working with a few of the representatives from Leech Lake and Fond du Lac is positive. They like what we're doing. The forecasts are good. The alerts, they're actually being included now. We're one of the very few agencies that actually mentioned the tribal nations in any type of air quality alert in the built-in. The environmental justice, I don't know yet. I know there's other people that are working with that are becoming aware, but we're trying to reach out to all those areas, whether it's in the rural tribal lands or into the Twin Cities area as well.
All right, Greg, do you want to go ahead and ask your question?
Hi, Daniel. It's good to hear your voice again.
Hey, Greg. Good to hear from you.
And to see your face. Thank you very much. That's very interesting. And it looks like this is being recorded, which is, I know some people who would be interested in watching this. So thank you for that. The question I have is, we had some fires over here in South Minneapolis recently. And I know Sven Sundgaard posted a little video clip where he was showing the 3rd Precinct fire extending on radar about 15 miles downwind. I was wondering if you have seen anything or noticed anything from those South Minneapolis fires.
Yeah, I happened to wake up in the middle of the night and I saw that radar plume, and it was interesting, and I was like, yeah, it made sense. The monitors that we have, there's one at Phillips and one at Near Road. They were north of the fires, and the wind was pretty much northwesterly for several days. So it carried down into Egan, here in Burnsville. You could smell it a little bit, but there was a purple air monitor or sensor in southeast Minneapolis and one straight southern Minneapolis. They did pick that up, and they shot up very high. I did talk to it was a Kenny Blumenfield from DNR Climate Office. He said in their neighborhood visibility was down to probably a quarter, half mile. And he said it was really bad. So those sensors did pick that up, those purple air. So it didn't affect the overall air quality across the metro, but I know we did bump up our numbers a little bit for PM forecast because of that knowledge, that local knowledge of that in our forecasting numbers. The good news was, once the day, it was bad at night, we had the inversion. It was light winds, just northerly winds. It did disperse during the day, but unfortunately, when there were those two or three nights when it was really bad, with leading into the weekend, we did notice that and did take that into account. It was, you couldn't really just write. I don't know. We didn't know how to write that into our discussions, but at least we mentioned that there was smoke in the Twin Cities, and that the numbers were up a bit. So hopefully we don't have to deal with that again. That's a different story than recreational fires. We do see those around the metro. If it's a nice evening, you'll see a lot of those, and the monitors will spike up a little bit, and we do account in our forecast for that as well. Hopefully that answers your question.
Yes, thank you.
Well, Dan, hey, that was absolutely great talk. I don't know if there are any other questions out there, but your work makes my work look positively easy, I think, looking at everything you do. So hey, thanks a lot for the insight into what you're doing.
Yeah, thanks for having me, and I really appreciate it. And this is it's a team effort. Our team, and work with so many other units and teams in the agency. It's just nice to be able to share what we do. And if there's any questions or any needs, I think any of us can try and answer questions or help out.
Great. Any other questions out there?
We have one more
we have
question,
one
it looks
more here.
like. Have you noticed any change with the decrease in driving during the last few months?
That's a separate thing with the COVID-19 reductions. We have talked about that with the nitrogen dioxide, the NO2. There have been reductions in that notice, not in the satellite data, and also in the 3 stations that would report NO2 in Blaine, downtown Minneapolis, and in Lakeville. There have been reductions that, especially in March into April when we had the stay-at-home orders. It didn't really affect ozone because we weren't in the ozone season yet, and PM2.5 actually was not affected. In some cases, it was a little bit worse because we had more people home, more recreational fires. So that was the offset of that. But we did notice the reduction, at least in nitrogen dioxide.
So it's not altogether obvious what's going to happen when people stop driving, it sounds like.
Yeah, it definitely takes time. Some things are more immediate than others, so it'll be interesting.
All right. Well, I think that is it, unless anybody else had a question. I did post in the chat the YouTube channel where we post all of the recorded water issues talks. So it takes me a little bit of time to get that posted, but we will have that up there as soon as I have a chance to get the recorded off of WebEx and post it there. So otherwise, We've got the next water issues talk will be Brian Johnson from Met Council to talk about their lake monitoring and assessment program. So thanks, Daniel, for joining us today. We had a great turnout, as we have been seeing lately with these new online WebExes. So thanks for taking time to talk to us about your work this morning. We appreciate it.
Yeah,
Thanks for having me. Appreciate it.